Now we'll explain two-phase method in that. That is second problem. In this second problem, this problem is having both phases, first phase and second phase. Right. We'll explain this problem now. Minus 0.75 right, minus 7.5 x1 minus 3x2, that is equal to minimization of z. That is minimization of z equal to minus 7.5 x1 minus 3x2 subjected to these two constraints. Now in the phase 1, we'll start the phase 1. For phase 1, we have to convert this minimization of z into max of z. Right. In this max of z, multiplying minus 1 on both the sides, max of z dash, that dash indicates minus 1. Now plus 7.5x, that is minus 7.5x, minus becomes plus 3x2. Right. Now first constraint 3x1 minus x2 minus x greater than equal to 3. If greater than equal to sign is there, we have to add surplus variable and we have to add artificial variable. This condition I have explained in big M method. Please follow the same thing. 3x1 minus x2 minus x3 minus s1 plus a1 is equal to 3. This is having 0 as coefficient in the objective function. This is having minus 1 in the objective function. Please remember this. Next, x1 minus x2 plus x3. S1 already written because of greater than equal to sign. This is s1. Now we have to write here s2 as a surplus variable, and it is having coefficient variable as 0 in the objective function, a2 plus a2 minus 1 in the objective function. Now x1, x2, x3 I have forgotten here. x1 and x2 are here, but x3 is in the constraint. We have to consider that also in the objective function. Now I have to write, as per phase 1, I have to write auxiliary objective function. Auxiliary objective function is nothing but converting these x1, x2, whatever values are there, by converting 0. Here a1 and a2 will be remain same. That is 0 x1 plus 0 x2 plus 0 x3 plus 0 s1 plus 0 s2 minus a1 minus a2 is the auxiliary function, auxiliary objective function. Right, this is auxiliary objective function. By using this auxiliary objective function and these two constraints, we have to solve it by simplex method. Right. Now, basic variables already we have explained in big M method. Whenever surplus variable or greater than equal to sign is there, always a1 and a2 will become your basic variables. Right. Please keep that in mind. If less than equal to sign, we are adding slack variable. That slack variable will become basic variable. Here it is. Both are having greater than equal to sign. Both are having greater than equal to sign. Because of that, we are adding one surplus variable and one artificial variable. When you are adding two, a1 will become artificial variable will become your basic variable. Both are greater than equal to sign. Because of that, a1 and a2 will become the basic variable. And a1 and a2 were having minus 1 and minus 1 as a coefficient in the objective function. 3 and 2 are the right hand side of the objective function. For constraint, right. Next, first constraint 3 minus 1 minus 1, 3 minus 1 minus 1. Please keep that in mind. x1, x2 are there in the objective function. Only x1, x2 are there. x3 is there in the constraint. We should consider that also in the variable. So x1, x2, x3, s1, s2, and a1 and a2. So these are the variables. Basic variable are a1 and a2. So first constraint, second constraint, we will form the table. After forming the table, right, after forming the table, we have to calculate delta z at the beginning. Now in delta z can be calculated by using the formula cb into xj minus cj, that is nothing but minus 1 into 3 minus 1 into 1, that is minus 4 minus 0. So minus 4, like that we have to calculate all the delta z values. From delta z we should consider most negative element. Most negative element is nothing but minus 4. That most negative element will give entering vector. Right. By this most negative element entering vector column, we should calculate minimum ratio. xb by xk, 3 by 3, 2 by 1, 3 by 3, 2 by 1. From these two, we should consider least positive element in the minimum ratio. That least positive element will give leaving vector. Right. Leaving vector, this x1 will be entering, a1 will be leaving in the second iteration. Right. Now intersection of these two is equal to 3. Now that is called as key element. Key element should be always equal to 1. If it is not equal to 1, we should convert that key element into 1 by dividing whole the row by 3. That is from xb to a2. We should not consider coefficient of basic variable. From xb to a2 we can divide. Now that is called as r1, r2, r3. Now r1 will be replacing here. I have written, you can read that later. R1 will be replacing here because key element is not equal to 1. If key element is here, only key element is 1, then R1 will be reference will be considered this only. Now because of it is not equal to 1, R1 will be replaced here. This row will be considered as reference plane, reference row for calculating or writing the equations for R2 and R3. Now dividing 3 by 3 will get 1, 3 by 3 1, minus 1 by 3, minus 1 by 3, minus 1 by 3, right, 0 it is 3, please consider it as 3, 0 by 3 0, 1 by 3 0. So like that, after converting dividing 3 will get this row, right. Now other than this key element, we should make this and this value as 0. To make this value and this value 0, we should write an equation for R2 by considering R1, this equation. Now R1 has been replaced here. Because of that, R1 we should not consider this, we should consider this row. Right. Now by considering this R1 has been replaced here because of not equal to 1. R3 also have to write the equation. I have written here, written below. Please go through that. R1 for R3 also written. Please go through that. And then we'll get these tables. X1 has been replaced here, A2 as it is, but these have been replaced by using equation. This has been replaced by using equation. We'll get delta Z values. Again, from our delta Z values, minus 4 by 3 is the most negative element. Once again, it is entering vector. Once again, you have to calculate minimum ratio by using x3. 1 by minus 1 by 3, 1 by 4 by 3, nothing but 3 by 4. Here it is 3, minus 3 will get, but negative element we are not considering for minimum ratio, only least positive element. Positive element it is indicated, no negative element, right? This will become leaving vector. Now this is leaving vector, this is entering vector, that is x3 is entering, a2 is leaving in the third iteration, right? Now intersection of these two is 4 by 3, but key element as per rules it is equal to 1. Now it is not equal to 1. So what we have to do? Convert this key element into 1, right? We have to convert that element into 1. How to convert? Just by multiplying 3 by 4 to the A2 row, except CBV. From this to this, XB to A2, we should divide or multiply 3 by 4. 1 into 3 by 4 is 3 by 4. 0 is 0. 3 by 4. 3 cancelled, it is a minus 2 by 4, 1 by 2. 0. 1. 1 by 3, 3 by 4, 3 cancel, 1 by 4. Like that, multiplying 3 by 4 will get this value. That is key element now equal to 1. Right. Now, this R5 has been replaced here because of key element is not equal to 1. Now R5. By considering this R5 row, we should write equation for R4 and R9. Right. R4 and R9. R4 and R6. Should write the equation for R4 and R6. Right. R4 is having minus 1 by 3. To make it 0, plus 1 by 3 we need. Because of that, equation is nothing but R4 is equal to R4 plus 1 by 3 R5. That has been explained. For R4, R4 plus 1 by 3 R5. For R6, R6 is minus 4 by 3. That is 4 by 3 R5. To make R6 value minus 4 by 3 0, 4 by 3 R5 is equal to 1. That is 4 by 3 is equal to 0. These two equations, R4 and R6, will be applied. After applying R4 and R6 equations, we'll get this table. Now A2 has been replaced by X3. X3 is having coefficient 0. Right. After applying the equations, we'll get these values, this table. In this table, delta Z values are positive. Delta Z values are positive. That means it reaches a solution stage. But we should check whether basic variable column at the end of the iteration, whether there is an artificial variable is there or not. Now in this column there is no artificial variable. Because of that, this problem will be moving or entering to the second phase. In the second phase, except this artificial variable, except this artificial variable, this complete table will be considered. Please go through the box I am making. So that complete box will be considered same as it is for phase 1. This complete box, and these values will be changing. These values will be changing. No artificial variables are considering. Now, because we are considering original objective function, because of that coefficients are changing. This complete table will be replaced in the second phase of the problem. In the second phase, you can check x1 is having minus 7.5, right? X1 is having minus 7.5, x3 is having 0, or rest of these values are same, right? And Cj's are nothing but these values are right, because A1, A2 we are neglecting. Here also neglecting, here also neglecting. We are neglecting total artificial variables in second phase. Right, only we are considering variables. Now, after replacing only this part, we are replacing, not other than this part, because of we are considering original objective function. We are replacing this part and this part. After replacing these two, we should solve once again for delta Z value. After solving delta Z formula, solving delta Z equal to C dV into xj, this into this into this. 7.5 into 1 is minus 7.5 plus 0 minus of minus 7.5 is equal to 0. Like that, we should solve for all. There is no negative element in the delta Z value. Means solution stage has reached in second phase also, at the first iteration only. So that the value of x1 is equal to 5 by 4, x3 is equal to 3 by 4. Now we should keep these values x1 and x3 in the objective function which has been written here. Or you can solve it, we can keep in minimization of z also. Now x1 is equal to 5 by 4, x3 is 0 in the objective function, x2 is equal to 0, only x1 equal to 5 by 4. Put x1 equal to 5 by 4 and calculate the value of max of z. Thank you. Now assignment problem, please try to solve these two problems. You will come to know how to solve this two phase method. Right. Thank you.